I like to start problems by just reading through them carefully and trying to get a picture of what's being asked. So a helicopter lifts a load vertically off the ground. Let's draw a little helicopter. And it's got a rope over there. Some little wheels on it. So there's the helicopter, and it's lifting some or other load. There we go, off the ground. Vertically, so we're working in the vertical plane over there. It accelerates at 5 meters per second squared vertically upwards. Immediately I can go, force resultant is equal to whatever the mass of that object is multiplied by 5 meters per second squared. We know that. If that's the acceleration, that is going to be the resultant force. State Newton's second law of motion in words. This is so often the introductory question. You really need to learn how to state this. And remember how I told you that you would have to be able to state it. So we're going to say F is equal to ma. What does that mean to me? It means that if a force is applied to an object, that object will accelerate. And the acceleration, I rearrange this, is directly proportional to the force and inversely proportional to the mass of the object. So that's how I always remember to state Newton's second law. Draw a labeled force diagram showing the forces acting on the load. So on this load, obviously this load has a weight. But it is moving upwards. They tell me it's being lifted off the ground with an acceleration of 5 meters per second squared, which means that there must be something pulling it up, and the thing that's pulling it up is the tension in the rope. Now, if I'm going to draw a labeled force diagram, this isn't unacceptable because force diagrams are not too fussy, but let's say that asks for a free body diagram. I would need to write weight, and I would then need to make the tension longer than the weight, because if the box is moving up or the load is moving up, the upward force has to be bigger than the downward force. Now it asks me to calculate the lifting force exerted by the rope. The lifting force of the rope is the tension in the rope. If the mass of the load is 100 kilograms, so they've given me a bit more information, which is great because remember we wanted that mass at some point over here. And we find that the resultant force is 500 newtons. But that's the result of the tension and the weight. Don't forget, the weight is acting down, and it is 100 times 9,8. So we know that the downward force is 980 newtons. And then we're going to say, force resultant is equal to the bigger force minus the smaller force. This is a principle we can use over and over. If I'm looking for the resultant of these two forces in the same plane, I can take the big force and take away the small force. No problem at all. The resultant force we've just worked out is 500. The big force is what I'm looking for, the tension in that rope. The small force is 980 newtons. It is the weight. And I then rearrange that, and the tension turns out to be 1,480 newtons. I just have to take that to the other side. We've got this block. It's placed on, and I'm told it's 2 kilograms, it's placed on a frictionless horizontal table and is connected via a pulley by a light inelastic string to a block of P of unknown mass, initially at rest. Block P, after falling 20 centimeters, reaches a speed of 1,6 meters per second. Sketch a fully labeled force diagram indicating all the forces acting on the 2 kilogram block and block P. So the 2 kilogram block has no friction. There's only one force. It's the tension in the rope. That's it. Block P has got a tension holding it upwards. I lie, it's not it. It's the only one that causes motion. There are 2 other forces here. There's weight and there is a normal. But they are entirely balanced. So it's not, but if you have to do all the forces, you do need to put those 2 in as well. And that's tension, and don't forget that block P must have a weight. Don't forget, you can't just use abbreviations, you have to write the words out completely. Calculate the acceleration of the 2 kilogram block. Well, force resultant on the 2 kilogram block is equal to mass times acceleration. I don't know the acceleration. I do know the mass is 2. I also know that force resultant is always equal to the big force. In this case, the big force is pulling it forwards, tension, minus the small force, and in this case, there is absolutely nothing pulling this backwards. So the small force is 0. So we have got a tension, an acceleration. So tension is equal to 2 times the acceleration. Imagine if we could find out this acceleration. We've got quite a bit of information. We've got a distance, we've got a speed, we've got the fact that it was initially at rest. What about using equations of motion? So I am going to say v squared is equal to u squared plus 2as. I know I'm working with block P now, which is fine. We'll see how it links to the 2 kilogram block in a minute. So v squared, the final velocity, is going to be 1,6 squared. The initial velocity is 0 squared, 2 times an acceleration that I don't know, and then I need to change this 20 centimeters into meters, so it's 0,2 meters. When I rearrange that, my acceleration comes out to be equal to 6,4 meters per second squared downwards. That's the resultant force on block P. I'm sure you all agree with me that block P and the 2 kilogram block must be moving as one unit. They are connected by a string. So if P is accelerating down at 6,4 meters per second squared, the 2 kilogram block must be accelerating across at exactly that acceleration. So let's substitute that in. 2 times 6,4, and I land up with a tension over here of 12,8 newtons. That tension, remember I've spoken to you before, that tensions must be equal to each other if they are in the same rope. So that tension must be equal to this tension over here. So let's see what they're asking me. They want the mass of block P. Let's do a little calculation. Weight is mass times gravitational acceleration. It's the big force. Force resultant is always equal to the big force minus the small force. I think about what direction is everything moving. It's all moving in that direction, and therefore the big force is weight, the small force is tension. So in this case, it's mg minus the tension, and force resultant is mass times acceleration. So I've got mass, I don't know mass, I've got acceleration, it's 6,4. I still don't know mass. I know gravitational acceleration is 9,8. And I do know the tension, because I've just worked it out, is 12,8. And then I can solve for m, and I find that m turns out to be 3,76 kilograms. Make sure that you pause the video and you've managed to make that happen on your calculator.